Gödel's rotating universe. What if I told you that, mathematically speaking, time travel might already be possible, at least on paper? In 1949, the legendary mathematician Kurt Gödel proposed something that could rewrite everything we think we know about time. He wasn't just any mathematician, this was the same genius behind Gödel's incompleteness theorems, which shook the foundations of mathematics itself. And when he turned his attention to Einstein's general theory of relativity, what he found was nothing short of mind-blowing. Gödel discovered a solution to Einstein's equations that described a rotating universe, a cosmic dance where space and time weren't just linear, but could actually loop back on themselves. In this model, time wasn't a one-way street, it was a circular highway where, theoretically, you could travel along a certain path and end up in your own past. Yes, that means time loops could be a built-in feature of our universe, if Gödel's model were correct. So how does it work? Imagine the entire universe spinning like a giant whirlpool. As space twists, time gets caught in the motion, forming what physicists call closed timelike curves, CTCs, pathways where an object or person could move through space-time and arrive at an earlier point. This essentially creates a time loop, a scenario where past and future aren't strictly separated. But before you start making plans to visit ancient civilizations, there's a catch. Gödel's universe requires a very specific type of global rotation, one that doesn't match our observations of the real universe. Modern cosmology tells us that while the universe is expanding, there's no clear evidence that it's rotating in the way Gödel's equations describe. So does this mean time loops are impossible? Not necessarily. Gödel's work showed that time itself might be more flexible than we assume, opening the door for other theories that could one day prove that loops in time are more than just science fiction.